Greetings and welcome to another installment of QuantSlab. This is 35 in our basic application series. This time around, we're going to continue on with our epic summarizing data series with part 7, Lucky 7. Very first order of business right from the get-go. Let's take a look at our previous QuantSlab horror challenge. How might we use pie charts to show a bivariate distribution between two categorical attributes? Well, we can use side-by-side pie charts. The chart on the left shows the distribution of off-speed or heater for pitches that are categorized as low velocity. Chart on the right here shows the distribution of off-speed or heater for pitches that are categorized as high velocity. And I think that this sort of works. We can see, for example, that heaters are much more prevalent among high velocity pitches than they are for low velocity pitches. Now there's something really important happening here, and we want to pay attention to it. We expect and even require that within any single pie chart that the percentages sum to 100. What we are in fact looking at here are conditional distributions, or conditional popularity, if you prefer. So for example, considering only low velocity pitches in our data, about 28% are heaters, well, about 72% are off-speed. Another more conversational way of saying this might be about 28% of low-velocity pitches are heaters, while about 72% are off-speed. Symbolically here, we can write our conditional proportion functions. The proportion of low-velocity pitches that are heaters is about 0.28, and the proportion of low-velocity pitches that are off-speed is about 0.72. Okay, second part of our challenge here. Our high-low velocity categorical attribute was created from a numerical attribute, pitch, start, speed. So, question, how might we use this original numerical attribute to convey the relationship between our off-speed or heater categorical attribute and pitch velocity? Well, that, folks, is the very topic of this present video. How about that? Showing the bivariate distribution of a numerical attribute versus a categorical attribute can starkly reveal patterns from our data. Now, typically in data summaries, our numerical attribute is conditioned on the categories or levels of our categorical attribute. So let's just jump right in here. Here, what we're looking at is a side-by-side horizontal box plot, and this is a very popular way to convey the bivariate relation between a categorical and a numerical attribute. Our heater, or off-speed pitch type categorical attribute we created has two levels, or categories. The original start speed, or simply the velocity attribute, is numerical in units miles per hour. So under the hood, the figurative hood, we are in effect subsetting our data by the categories. So for example, we look only at observations where our new pitch type attribute is heater, then plot the distribution of our numerical attribute for only these observations. And it's the same deal for the other categories. And here we have one other category, off-speed. Very importantly, we plot these numerical distributions with respect to a common axis or domain. Here, you can see that at the bottom. So why do we do this? By orienting the box plots to a common domain, we can visually compare the distributions across the different categories here. And there's tons of fun going on here, so let's look at a few highlights. Now, if we were reviewing this in a journal article, we'd likely have a table that would give relevant statistics for these two conditional distributions. But let's use this as an opportunity to sharpen our visual acuity here. Very first place I'd go with a plot like this is to compare the medians. The median, also called the second quartile, or the demarcates the 50th percentile. Okay, the median is famously known as a measure of center. So here, I'd approximate that the median velocity among off-speed pitches is about, 82.5 miles per hour. For heaters, maybe 92 miles per hour, give or take a little. So we could say something like the median velocity of heaters is about 10 miles per hour faster than the median velocity of off-speed pitches. To really punctuate the difference here that we have in this particular data set, we could also note that the 25th percentile of heaters is still faster than the 75th percentile of off-speed pitches. Now, The IQR, The interquartile range is a measure of spread, or how diverse or varied our values are. And just approximating things visually, the IQR of velocity for off-speed pitches is maybe close to 7. The IQR for heaters is tighter, narrower, maybe about 4, about. In the total distribution of velocity, or the unconditional distribution of velocity, just to harken back to this, the IQR is 9. There are other measures of variability, like variance and its close kin, the standard deviation that we might traditionally use here. But the general idea that we're conveying here is really important, and that is that the variability here, in this example, in terms of IQR, of the unconditioned attribute velocity is greater than each of the 2 conditional IQRs. Okay, stacked histograms, same basic idea. Here we use histograms to show the distribution of our numerical attribute for each category of our categorical attribute. And once again, very importantly, the distributions are rendered relative to a common axis or domain. Or we could say that the histograms are horizontally aligned. Now, for the sake of this video, I want us to pay attention to 2 things in particular. The first is that simply the distribution of velocity of pitches classified as heaters is, well, farther to the right than that of those classified as off-speed. Or to use more technical language, we could say that the mass of the distribution of heaters' velocity is farther to the right than that of off-speed pitches' velocity. And by mass, we're simply referring to the shaded region here in the visual, the histogram. The other property we want to recognize requires, again, that we revisit the full distribution of pitch velocity. Here's a histogram. The shape here is plainly lopsided. It is skewed, as in skewed to the left. The shapes of our 2 conditional distributions here are still a little left skewed, I would say, but at least visually, the skewness is not quite as pronounced. Moreover, here, the contours of the conditioned distributions are a little bit more smooth or bell-shaped. Now, before we close out, it's time for our QuantSlob challenge. Pitch type, as originally recorded in our data, is categorical attribute with 16 categories, or we could say that pitch type is a 16-level factor. So, question, how might we visually display the bivariate relationship between pitch velocity and this original pitch type attribute? We're going to pick this up in the next installment, along with lots more exciting stuff. You're definitely not going to want to miss that. That's it. That's going to do it this time around. Thank you very much for tuning in. Don't forget to stay tuned for more QuantSlob.